So before moving to set interface, we will see a topic named cursors. So cursors are used to retrieve objects one by one from the collection. I have explained this line before also, that what happens in cursors is, if this is my collection, okay, and if I want to retrieve object at a time, one at a time, then we will use cursors. Okay, we will use cursors. We will first retrieve this object, then we will retrieve this, then this and this. So one at a time, when we want to retrieve objects from collection, at that moment we will use cursors. We have three types of cursors. There are iterators, list iterators, and enumerations. So iterator, list iterator, and enumeration. Okay, so if you are confused with the name iterator, with the help of for each loop also, with the help of for each loop also, what we do, we iterate over our collection, but we can only traverse. We cannot manipulate that collection. But with the help of iterators or list iterators, what we can do, we can manipulate also these collections. Fine. So first we will see iterators. So iterator is nothing but it is a interface. It is an interface provided by the collection framework to traverse a collection for a sequential access of items in the collection. Fine. So it is nothing but an interface provided by collection framework. We can apply iterator concept for any collection object. So it is a universal cursor. We have seen three types of cursors. So in enumeration, that is a legacy classes cursor, but iterator is a universal cursor. By using iterator, we can perform both read and remove operations. So by using for each loop, also we can do read operation, but we cannot do remove operation. But using iterators, we can also remove it. Okay, remove the object. So methods in iterator are has next, next, and remove. There are three methods. That is, if there is more element, if I have this, what you say, so if I have my collection, okay, that is 1, 2, 3, and 4. Now, if there is a next element, that is has next. If there is a next element, then it will return a true. So if I am at the end and there is no next element, then it will return a false. The second method is next. So it returns the next element. So the first method returns true or false, whether there is a next element or not. The second method returns the next element. So if I am here and I call next, so it will return me a 2. That is, the next element is 2. That is the remove method. This method removes from the collection the last element written by the iterator. So I was here, I called the next function. The next method returns me a 2. Okay, so the last element that was returned to me was 2. So the remove method will remove 2. Okay, now we will see a simple code for iterators. We will use these functions, okay, so that you can understand it better. So let's create a collection that is an array list. Okay, we will create an array list, and the type parameter will be integer. Okay, just keep it simple. Then array list equals to new array list. Okay, so the name here, this small array list, is nothing but our reference variable. Fine. So the name here, array list, is nothing but our reference variable. Let me add some values here. So add 2. Fine. And we will add more values now. So let's add 3, 4, 7, 8, 9. Fine. So this is my array list. Let's just print the array list and see if all elements are added or not. So we have seen this when we were learning about array list class. Okay, so this add method is in the collection interface. So 2, 3, 4, 7, 8, and 9. Fine. Next, what we will do, we will create a iterator object. So iterator, we will pass the integer, because we know we have integer in the array list. Iterator, this is a reference variable, array list dot iterator. Okay, now you should have a confusion. Okay, now you should, if you are very clear with interface concept, you should have a confusion in this line. Why? Because when I explained you iterator in the previous slide, there was iterator is an interface. It is an interface, it is not a class. So why are we creating a reference variable for it, and why we are initializing it? Okay, why are we creating a reference variable for it? Let's see how this iterator interface is implemented, because normally whatever interface we have, that is list interface, the methods are implemented inside array list. That is the implementation class of the list interface, or by vector, or by stack, or by linked list. But what about iterator? Let's see what happens in the case of iterators. Okay, so what happens in the case of iterator is, I have my array list class. Okay, now this array list will contain the implementation of the method. For example, the method is nothing but next. Okay, the method is nothing but next. This next method, inside this next method, we will have an inner class. We will have an inner class. This inner class will implement the iterator interface. Okay, this will implement the interface, that is the iterator interface, and this class will return an object. This class will return an object. This object is stored in this line that we have seen, that iterator and here itr, for example, equals to anything. So here itr is a reference variable that is referring to the object that is returned by this inner class. So inner classes actually nothing else but inner classes actually implement the iterator interface. Okay, I will let's just say it. Okay, I will just print the class name. One second. So s out iterator dot get class dot get name. Okay, let's just see what is the class name that is written. So currently I am in array list, so therefore the get class name will have array list $, and itr. So this is for anonymous classes, that is we have many inner classes in array list, so we have that anonymous class. This is for anonymous class. If we have a linked list, then here we may have java.util.linked list. So this is why I am writing here iterator and I am creating a reference variable, because what array list.iterator, this one, is returning me, this iterator method is returning me. So this iterator method is in what you say the interface. It is in the collection and list interface. So the array list.iterator, this method returns me an object. That object is referred by the reference variable iterator. Okay, so now we can move on. Now we know that this interface, we are not creating an object for the interface. It cannot happen. We cannot create an object for the interface. Okay, we are not doing that. We are simply creating this a reference variable which is of the type iterator, because this method is returning an object. This method is returning an object which is of a type iterator. Fine. This is the only point which is confusing in cursors and nothing else. Okay, I hope it is clear with you. So the next what we will do, we will simply create a while loop, while iterator dot has next. Okay, while iterator dot has next. So while this is true, has next function returns true or false. If there is a next variable, it will return me a true. If there is not a next variable or next object, it will return me a false. So this was the first function, has next. So in while we will have either true. So this was the first function, has next. So in while we will either have a true or a false. If we have a next object, then it will be a true. If we do not have a next object, it will be a false. Okay, then I am storing the value returned by the iterator. So iterator dot next. So this will return me my object. This will return me my object that is of integer, because we have the type variable, the type parameter was integer, and it will be auto unbox to I. Correct? So auto boxing, unboxing, generics, everything is here. Fine. So I will store whatever iterator to next returns. Now this, if this I mod true is not equal to 0. So if this I is not an even number, that is it is an odd number, I want to print it. If it is an odd number, I want to simply print it. Okay, else if it is an even number, what I want to do, I want to remove that from the iterator. I want to remove that from the iterator. So the even numbers will be removed and only odd numbers will remain. Only odd numbers will remain. And at the end, what I will get my array list with the odd numbers which will remain, and it will also be printed, and all the even numbers will be removed. So using iterator, we can do some extra steps which we cannot do in for each loop. Okay, so we can remove. So let's see it. So as you can see, 3, 7 and 9, 3, 7 and 9, 2, 4 and 8 are removed, 3, 7 and 9 are left. Okay, so this was how you use iterators. So next we will see list iterators. So let's see what are list iterators and how they are different from the iterator. So it is an interface, it is also an interface that contains method to retrieve the elements from an object both in forward and reverse directions. Now this is important. Now in iterator we can only move in one direction, that is the forward direction. We only have has next. Okay, but here we can move in reverse direction also. We have has previous also. Okay, we can move in both the directions. So the methods in list iterator are has next. So it was also provided by the iterator, but it also has previous, because we can move in both directions, that is forward and reverse. So we also have previous. Then we have next, returns the next element, and we can now also return the previous element. Okay, so next and previous. Then we have the functionality of remove. It was also present in the last one. The extra method we have is next index. So now we can know the index of the next element. We could not know this in the case of normal iterators. We also have previous index because we can move in the reverse direction. So we also have previous index, the index of the previous element. The next method is set. So it replaces the last element, returns by the next or the previous. So this is also a new method that was not in the iterator. Okay, and add. So it can insert the element also. So we can do so many things using the list iterators, but the list iterators are not universal collection iterators. Because as the name suggests, it works only for the list interface, only for the classes in the list interface. The array list, linked list, vector, stack, only for those the list iterators work. Because this next index and previous index, these are the methods that are used by the list only, because they have indexes. But by set, the set do not have index. Therefore, they cannot use these methods. But since it is an interface, they has to implement. So therefore, only iterators are universal. List iterators are not universal. They are used by the list interface implementation classes. Fine. Now let's see some code. So for list iterator, let's create a linked list this time. Okay. So we have a linked list. We pass integer just to keep it simple, and linked list, a reference variable, new linked list. It's done. Now a for loop for I equal to 0 to I less than 5, I plus plus, declare it I plus plus, then just add. So linked list dot add, what we will get? I. It's very simple till now. Just s out linked list. Fine. So we will have 1 2 3 4 sorry 0 1 2 and 3 4, 0 1 2 3 and 4 as our output, as you can see. Next, what we will do, we will create an iterator. We will create a list iterator. So this is the same function. So how we can create an object? Similarly as we did, as I have explained you for the iterators. So the inner classes implement this and they return an object. So to reference that object, we are creating list iterator reference variable. Okay, equal to linked list dot list iterator. Fine. It is simple till now, no issue. Now let's see. While list iterator dot has next, while this is true, while it has next, what we have to do, we will simply store its index. We will store our index and we will call list iterator dot next index. Fine. Then we will store its value in I. So list iterator dot next. So next index will return me the index of the next element, and next will return me the actual element. Fine. So system.out.println element at index, it's simple, index is simply I. Okay, it's done. It's very simple. Fine. So this we can do with the help of for loop each also. Okay, so this we can do. So this is the output 0 1 2 3 4. So this thing we can do with the help of for each loop also. Correct. What we cannot do with the help of for each loop is remove, set, add. We cannot do these things. Now let me tell you one more specific point we will use. So now let me summarize what has happened till now. Okay, so let me summarize what has happened till now. We have our linked list. So keep in mind it is a doubly linked list. Okay, so whenever I talk a linked list class in collection framework, it is always based upon the doubly linked list. Okay, I have a linked list. Now I have traversed the linked list till the end. I have traversed actually the linked list till the end. When I use the function dot next, it not only gives me the next element, but it also iterator start pointing to the next element. Okay, it not only points, it starts pointing. Okay, this obviously will give me the next element, but it will also start pointing to that element. Fine. Have you understood this? If I am at 1 2 and 3 and I call next, I am at 1, it will return me a 2. It will also start pointing to 2. Then again if I call, it will return me a 3 and it will start pointing to a 3. Okay, understood this one? Now what we will do, now I am here, and now if I call has next, or not has next, sorry, now if I call the next index, now I can also call index in list iterators. Correct, I can also call index. So if I call the next index, what it will actually return me, there is nothing in forward, but what it will actually return me, it will return me the size. It will return me the size. Why? The index starts from 0, 1, 2, 3. Okay, now I am here. When I call the next index, it will return me 4. So in this case, it will not give me an error, but it returns the size. It returns the size. So this way, with the help of list iterators, we can also get our size. If I am at the end, we can also get the size. Okay, so let's see what it will return here. So s out list iterator dot next index. So if I write this, so the size of my linked list will be given. So the size is 5. So the size is 5. The output here is 5. So this is one of the use cases of next index function. Okay. Now since I am at the end, now what I can do, I can use list iterator dot has previous. So now I will be traversing my list from behind to front. Okay, from the rear to front. Fine. I will do the same thing. Previous index equals to list iterator dot previous index. Fine. So this is the previous index method. Now in previous, in p equals to list iterator dot previous. So this is a previous method. So what next was doing, exact opposite previous is doing. It will return me the previous value and it will start pointing to that node. Okay, so s out, I will simply print previous index plus my list iterator, sorry, the value of p, that is the previous node. Okay, so let's see what it will print. It will print the same thing but in a reverse manner. Okay, so I will have 4 4 3 3 2 2 1 1 0 0, but here I had 0 0 1 1 2 2 3 3 4 4. Okay, so this was previous index, next index, next previous method, has next method, previous next method. So has previous method and has next method. So we have done so many methods till now. We can also do some more method. For example, set method. We can also do set method. Fine. Now since I am at the beginning, now at this point, if I call list iterator dot previous index, at this point if I call this, so it will return me -1 because I am at 0. And if I call list iterator dot previous index, it will return me a -1. Fine. Now what I can do, I can use set list iterator dot set and 10. So I want to know what will happen if I do this. So let me print my linked list. Okay, so list iterator dot set 10. So where it will set the 10, let's see. So see, at the first one it set the 10. Why? Because now where I am, I am at 0. Okay, the previous index is -1. The previous index is -1. That means I am at 0. I think you can understand this thing. That is, I am 0 and I am at 0. Therefore, the previous index is -1. So I am currently here. So since I am currently here and I set 10, so this will be replaced by 10. So this is what happened here. Okay, so these were some of the methods of the list iterator class. So what is the difference between list iterator and a normal iterator is it can go in the forward direction and as well as in the previous direction. Also, it can give me the index of the next and the previous one, which iterator doesn't. But the second point is iterator is a universal cursor, but list iterator is not a universal cursor. It is only for the list interface, the implementation classes of the list interface. Fine. So these were iterator and list iterator. The last point we have is enumerator. It is only for the legacy classes. Okay, so the legacy classes are the classes which were in 1.0 version of Java. Okay, and the methods, it has more elements in the next element. These methods we have already seen, only the name is different. It is has next and the next. These are the methods, but since the naming conventions were different in the beginning, so therefore these names are different. There is nothing to learn in enumerator because iterator does all the functions of enumerator and it adds also. So the normal iterator has actually 3 methods: has next, and the remove. And enumerator does not have remove, so it is similar to for each loop. Fine. So these were cursors. Now we have completed our cursors. Now we can move to sets.